Hello, everyone. In this video, we are going to look at problem 3 from section 3.5 on related rates. So again, the more practice we have on working out related rate problems, the more comfortable and familiar you will be with them. So let's go through this one together, problem 3. So we are told that oil spilling out of a damaged ship is forming a circular circular slick on the surface of the sea, whose area is increasing at a constant rate of 125,000 square meters per hour. Well, that's a lot of oil. How fast is the radius of the oil slick increasing when its radius is 100 meters? So step 1, we draw a picture. Well, what picture should we draw? Well, we are talking about a circular slick of oil. I'm going to draw it even better. Circular slick of oil. And what are we given? Well, we're given the change of the area of the circle is 125,000 square meters per hour. So what we're told is that the change of area with respect to time is equal to 125,000 meters squared per hour. And so we want to know how fast is the radius of the oil slick increasing when its radius is 100 meters. So we need to label this circle with a radius. And part of our first step as well in drawing, actually, we already did our first step drawing. Now our next step is just to relate the quantities in our problem. So we have information about the area, and we want to find information about the radius. So we need to relate the area and the radius. So we can use the area formula of a circle. Area of a circle equals pi r squared. So now let's just go back and make sure we have written down everything we are given. So we are given the area. We are given that the radius is 100 meters. At the place that we are interested in. And what is it that we want to find? Well, we want to find the change of radius with respect to time at that 100 meter mark. So now that we have our formula or our equation rather between the area and that radius, now step 3 is we compute the derivative of both sides. So the derivative of the left is just the derivative of area. The derivative on the right would be, well, we take that constant out. So then we just use the power rule, 2 times r, and then dr dt. So now step 4, let's just plug in everything we know. We know dA dt. I'm going to use a bigger highlighter there. We know r. So now we just need to find dr dt. So dA dt is 125,000. So that's equal to pi times 2 times 100 dr dt. So now we just need to solve for dr dt. So to do that, we're going to divide both sides by that pi times 200. So we get that dr dt is equal to 125,000 over pi times 200. And if we compute that out, that's going to be about 199 meters per hour. So the speed that the radius increases when the radius is at 100 meters is almost 200 meters per hour.